All right. So thanks everyone. So my name is Martin Bishop. I'm obviously with AWS. I lead the solution architecture team for public sector in the UK. And really, you've heard, anybody here heard about Lambda?
Just once.
Just once? Okay. I might mention Lambda. API gateway, anyone? Yeah. Okay. S3, DynamoDB, so a bunch of stuff. I'm not going to talk about, hopefully, a lot of the same stuff. I'm going to touch on some of it. But really, the aim of this talk is really, if you've got an application, how could you actually practically, what kind of application, how do you actually get started? Technically, how do you actually just get into this and build a simple application? So I've got a really simple website. Oh, it's actually not that simple. It's really simple for me because I don't need to operate anything, and I've used all managed services, and I just leave it there, and it just works when I need it to. But we're just going to basically look at that, look at the console, do a bit of a practical, and see, what does it look like if these functions and tables and all this stuff is defined. Okay. So traditional web app. So how would I have built this this voting application? So the use case that I've had here is, I'm running the next pop idols, I guess, tech idols, and I want to be able to provide people with the facility that they can vote via SMS. In my case, I've only got 3 participants, and they are colors, but anyway, we'll park that. Previously, I would have maybe said, okay, look, I need to be on the internet, so I'm going to need a DNS name, so I'll use route 53. Because I need to be on the internet, I'm going to need an elastic IP, and I can point that at an EC2 instance, have a little MySQL database on there, Nginx or whatever your web server of choice is, write a bit of code, pretty straightforward. Not that bad. Having a database on my EC2 instance is probably not the best thing to do, so I could use a managed service like RDS and let AWS manage my database for me, make sure it's backed up. Slightly better. If my application consists of multiple parts, I could split it out and say, look, I'm going to have a front end, so this might be potentially publicly accessible, bit of an application layer, an app server, and that talks to my database. Again, slightly better. Or the way you do it properly on AWS, use auto-scaling groups, set up your servers so they start from basically the bootstrap data or from the AMI. Use RDS in a multi-AZ capability. Use load balancers to make sure your traffic gets distributed appropriately. So if you've used AWS before, you've probably built something like this. And if you haven't, you will probably build something like this if you choose to use AWS. And it's a good architecture. It's great. Lots of people do this. Literally thousands and thousands of organizations run workloads just like this on AWS very successfully. But the challenge with it is that you've still got one thing, all these servers to manage. So all these servers are still basically, as per our shared responsibility model, which might have been mentioned today, we'll take responsibility up to a point. So to your questions around, password policies and all that stuff, on these servers now, you're going to have to be responsible for patching them, making sure they're secured appropriately, who gets to log on to them when, just the whole management cycle around the servers. So yeah, it's pretty good, but it's still quite expensive potentially to operate in that manner. So mobile apps kind of force the point somewhat, and they give us an opportunity, and I think this is sort of driven a different way in terms of designing applications where you've got a rich front end, if you like, and that front end relies primarily on APIs in the back end. So started, maybe you could sort of argue that it's primarily driven through apps have really driven the change, but many websites now operate in the same way. You have a bunch of static content you download. You've got some JavaScript that actually runs on the client, so the dynamic stuff's happening on the client instead of generating static content and pushing that down to clients. The clients actually generate their own content with JavaScript, and they rely on APIs in the back end. So clients potentially, as I said, mobile apps to begin with, but nowadays many websites implementing sort of Ajax or that kind of methodology. This is just how stuff works. Does this make sense so far? Okay.
Can you make it as interactive as possible? You almost make it like a masterclass, so if people want to ask questions while we're going through this.
Yeah.
Let's do it that way as opposed to waiting for the end.
Okay.
Yeah.
With the machine.
With the.
Okay. The catch box. Yeah.
Oh yeah.
Quickly talk into it for me so I can check that.
Hello.
Hello. Thank you.
So this
Okay.
is the end, I'll give you that. We can actually keep going as we're going through it.
Okay. So yeah, as I said, now you can also implement this with API Gateway and Lambda. So obviously the benefit there, not having to manage a lot of this infrastructure, all the stuff you guys have heard today. I'm not going to keep repeating it, but yeah, lots and lots of benefits with serverless that you can focus on writing your application, working on your business logic, and what I've also got to do in this picture is I need to be sure I'm ready to scale. If I've got an event that's going to come up, or my tech idols goes viral, I'm going to have to sort of be ready to suck up this load. Again, with serverless, you don't really have to worry about that as much. Any questions?
I'm just getting the ball queue.
Oh,
Hi.
Hi.
As a Lambda newbie, if we've got a bunch of web services that we're currently using for our website, how easy is it to wrap those up and convert them into Lambda? I really don't know.
I hate to give you a consultant's answer, but it depends. Happy to talk afterwards. So it really depends on how you've implemented it. If it's Java, for example, you can do a wrapper around Java, and yeah, as long as there's no state, for example, on your web servers, that kind of stuff. If it's really stateless and you're running it at, say, in an EC2 fleet, that kind of thing, and it's event-driven, or you can drive it via schedule or an API, then it's definitely doable. There's a few constraints around the maximum runtime. So maximum runtime for Lambda at the moment is 5 minutes. And there's also a RAM constraint of, I think it's around 1.5 gigabytes at the moment. So it really, it requires a bit of diving deeper. But yeah, lots of people have done it, and it's very easy to do a proof of concept. So you can also, with Lambda, this is going off beat a bit, but a use case I've had recently is we did a hackathon with TfL. And TfL have got great data. They've got all these sensors in the road. If you drive over it, you get a 1. If there's no car on it, it's a 0. Simple. It samples every quarter of a second. They've got loads of them all over London. And we had all this data. So with that, I had a C native application, compiled application, that University College of London actually developed. So I didn't have the code to go and refactor that, but I could wrap, using Python as a wrapper. You can also include the native C. So I basically included the native C, wrapped it with a bit of a Python script, and was able to use Lambda to basically transform all those files. So it's a Linux environment. You can do a lot in there. That's not just doing API-driven stuff. You can even include native compiled binaries. As long as those run on, say, Amazon Linux, you can run those within your Lambdas as well. So, sorry, I don't know if it exactly, happy to talk afterwards. Okay. Anything else? Any other questions? Okay, so where do we want to get to? In this example, we want to get to an application where it's all managed. So using API Gateway as the front end, Lambda as basically our compute engine. We're using something that you might not have encountered today called Cognito. So I'll just do a very quick intro into what Cognito is. So Cognito provides you with an identity management. So it's got a couple of parts. But basically, I think for the purpose of this talk, just know that this Cognito helps us manage identities, whether they are federated identities or identities that we manage on your behalf. So you can have an AWS identity pool, bunch of people that use your website, or you could federate in from what your organization should have done, federate in from Active Directory and just track that person as an identity in your application. So first building block, Lambda. So instead of showing you more slides, I think I'll just pop into the console. If this works. Okay, can you see that? Okay. So I'm not sure this is the best way to try and do this, but here we go. So this is Lambda. If you go in here, you can see we've got a number of Lambda functions. And in this case, this vote natsec is my Lambda function that I'm going to talk about. So come in here, and we can see actually, you could edit the code in line, or you can create a zip package that includes, if you have binaries, for example, or your Java application, you'd actually create this Lambda package and deploy that to your Lambda function. You've got some configuration. My internet's not great. We'll get there. While that's loading, let's have a look at this. So this is the application. Okay, it's hosted primarily in an S3 bucket, some static content, and then it's got some APIs and the Lambda running in the back end. So coming back to Lambda. Right, so the code's taking a bit of time. So I'll skip that. So in the configuration, you can choose the runtime, so whichever runtime environment you want to use, where you have to enter, where this function enters, which role your function should have. So this is really an important thing to point out with Lambda as well, and Dave might have mentioned it earlier, but if you deploy it onto EC2, what you would have is EC2 roles. So it basically means you give this server permissions to do these things within your AWS environment. The crazy thing now is, well, not crazy, the great thing now is that you can actually give a function access to specific things in AWS. So if you had a web server that had to be able to grab an image from somewhere or update a DynamoDB table, whatever, you'd actually have to give permission if you used EC2 roles to the whole instance to do it. So it basically meant if somebody got onto the instance, they would be able to potentially do what that instance has the rights to do. With Lambda, though, you can be very granular in terms of you can have a role per function. So if I've got an add user function, I can write to the users table in DynamoDB. But if I'm a check user function, I've got no business writing to any tables. I just want to be able to do a quick read. So you can use AWS's identity and access management platform to do very, very granular access control in applications, which honestly, if you try and do that in your own applications, it becomes super hard. You're shaking your head. Sounds like you might have tried to do it. It's not easy to do. Okay, the triggers are the events that will cause this Lambda to fire. So I haven't got any triggers, but this could be, for example, as Dave had, someone put something into an S3 bucket, or something goes onto a Kinesis stream, or a bunch of different sources like that. And I can see, when my function's been invoked, and I get some monitoring data around that. Okay, so that's the Lambda function. If I pop back here. So the second building block to all of this is we've now got this bit of code. This bit of code expects an input. The input in our case is a color, red, green, or blue. And we need to get that, what was that? Was that Alexa? We need to somehow get that to our function. So the way to do that is to use API gateway. So I've set up an API here. So it's the vote API. It's only got one method, which is a post. It's not doing anything special in terms of authentication. And the integration request is basically to run my Lambda function. So if you call this method, it's just going to fire off my Lambda, and my Lambda is going to do what it needs to do. And I'll show you what that is in a bit. And it'll get back to the caller. So see if this is loaded now. Okay, well that's right. Then I really want to show you the code. Anyway, we'll get the code. On comments, we'll get there. This application needs a very basic table to store some data. It's nothing complicated. So for that, I'm using DynamoDB. Literally gone into DynamoDB, said create a table. And when you create the table, you've got certain things that you can configure. And the key part that you really need to manage when you're using DynamoDB is to configure the capacity. So 2 elements. How quickly do you want to be able to read this table? How quickly do you want to be able to write to this table? So really, I mean, you can't really get much more simple than that, than just completely not worrying about capacity. So what this means is you can have 20 reads per second and 10 writes per second. And you can scale these up as required. And they're not fixed at table creation time, so they can also flex in and out somewhat. Okay, so if you actually have a look at the data within the table, okay, I'm going to park that for a second. Okay, so what API Gateway has done is it's given us this front end, and that's now accessible from the outside. We've got the DynamoDB table, which I'll show you in a bit, and our Lambda function. So what the API Gateway is providing us is, it provides functionality that we can cache API calls. So if you've got primarily a read-only API, like what would be a good one, like the Met Office, I guess. They spoke yesterday. So if you're looking for a forecast for a specific area, for example, it might make sense for us to cache that for you for half an hour instead of going back and hitting your backend servers. It provides you with a DDoS protection because CloudFront is baked into the API Gateway solution. So the endpoint that you get on the internet is already protected by CloudFront. And you can import and export your APIs as required with the Swagger functionality. So sorry, is there another Wi-Fi network I could use?
UIC, you had it in your list.
Yeah. This one.
Urban innovation, capital U, capital I.
Sorry?
It might be that it's too many connections.
We've even had something here on the back.
I can take that.
There's no technologists in the room, so.
I think we're, it's good. We're good.
Is it working?
Yeah. Okay. So
I
let's.
just need to say, I'm getting the technology
Yeah.
right.
Yeah. Okay. Great. This has suddenly gotten a lot easier. So this is the table. So you can see it's got 3 records. It's basically just going to increment these, when we get a vote. What the Lambda function does is literally just read the current value, look at the value that was voted for, and increase it by 1. So the Lambda stuff should work as well now. Yeah, great. So this is the code. So in this case, it's Node.js. You can see in here, it's basically doing what I mentioned. It's going to just extract the color, get the current value from DynamoDB, and just increment it with 1. And so you can see at the moment we've got 977, and that's our setup. Right. So another element in all of this is Cognito. So I mentioned Cognito provides you with this temporary identity. So what the web front end, so that's vote.ns.sademos.net, what that's actually doing is there's JavaScript running on the client side that is querying DynamoDB directly. So you'd notice I didn't have an API to say get current votes or anything like that. You can actually offload that, give the web client credentials to do what they need to do directly against the AWS services. So in this case, for example, counting the reading the number of votes, but obviously you wouldn't give them access to write the votes. So again, you're using AWS's security module to enforce access to data within your application. Okay, and then the final element to all of this is we need a caller. So in our case, the caller is Twilio. So there was a phone number on that site. So that if you SMS a color to that, that would call Twilio. Twilio calls the vote API that we've exposed via API gateway. That fires off the Lambda, which updates DynamoDB. And we've got the S3 client that's coming in via Route 53 and DNS, and has credentials to query the Lambda, the DynamoDB data directly. Okay. So, do you mind giving it a shot, Matt? So if that's the site. Yeah, so you can see it's quite responsive. I guess you're voting for red, Matt. Yeah. So, yeah, it's 20 quid per SMS. Yeah. Yeah, I'll be okay. Yeah, so that's it. It's really simple application. Happy to take some questions. Sorry, it was a bit bumpy with the access. I don't want to present lots more slides to you. I'm sure you've seen a lot of slides. So, yeah, happy to take any questions.
So my question, I have dev and test and production for this website. I have written one Lambda function, and I want to pass only and I have 3 S3 bucket, one for dev, one for test, and one for production. From those bucket, I want to get this color or whatever the image. So I want to write one function, but pass the config of that environment. So is there any provision we can pass config environment specific to Lambda function?
Yeah,
so I don't want to write 3 Lambda, or 3 different environment.
Yeah, so Lambda has an, forget what it's called, Matt. It's an alias. So API gateway, you would use stages. So you could have a stage for dev, test, production, for example, on the API gateway side. And then Lambda, it's the...
Just released environment variables. So you can define your environment variables to say whether it's production or dev or test, and then the code can respond to those environment tables appropriately. And then we have aliases that respond to different versions of Lambda code. So you can have version 1, 2, 3, you can label version 1 as prod, 2 as test, and 3 as dev. As you increment the versions, you can then point the aliases to particular versions. So you can always keep prod on a particular version, add 4 or 5 more, test them, and then when you're happy, change the alias for prod from version 1 to version 5, and then all new executions run against that new version.
Cool. You?
You showed writing an API using the UI. I'm assuming that you can do all that on CLI.
Yeah, definitely. So normally, I mean, Dave mentioned it, you would create a Swagger type package and just create your API with that. Or the within serverless, what's the cloud? Serverless application model, SAM, which now lets you use CloudFormation to wrap up your Lambdas as well as your API. So it's basically, it's CloudFormation for serverless. So it lets you do what you would have done with infrastructure using CloudFormation. You can now do that for your serverless applications as well.
I was intrigued about the Cognito, and let's say I have this type of use case. I'm already I'm using a third-party API provider for handling authentication and authorization. I want to move to AWS, but I've got all my users with all the credentials, typically with app ID, app key. I might have OAuth, or I might have another type of authentication method. And if I want to migrate, I need to migrate all my users as well to this. Is Cognito basically allows to import identities from a third party, or how does it work if I want to migrate rather than start from scratch with it?
So I think there's probably two approaches. One definitely is to migrate, and absolutely you can bring your user base across to Cognito pools. So pools is the bit that lets you manage your own users. So that is an option. If your existing identity provider though supports OAuth, for example, chances are very good that you could continue to use them. You know, so with this, it's not an all or nothing sort of thing. You can use bits of their technology, and all of it is, I think, designed so that, you know, there's standard ways to federate in, for example, like OAuth. So you would federate in from your identity provider into Cognito, which would give you temporary AWS sort of land credentials, and then you could use those credentials to, you know, access AWS specific services. Or you can move your user base into Cognito pools, and yeah, there's functionality to obviously bring them across in bulk. Or Cognito pools also supports the sign-up use case and a few use cases that, you know, you might have had to implement previously with your application. So you know, when a user signs up, you can send the verification email, send a verification SMS. That stuff's just taken care of. It's all part of the service. So when you configure your pool, you can define those configuration elements. You can also define requirements around multi-factor authentication. You know, when would you require that? So, you know, it's a service in its own, but it's definitely not mandatory to use it to build applications like this.
Does it help also to prevent abuse? Let's say I've got a free tier, I'm providing my API, you know, you can have X number of requests, and then the user opens, you know, 10 different accounts with the same email address or a similar one.
You can have unique addresses. I think you can store information, some metadata about users connecting. I think if you're talking about API, you know, providing API keys, for example, then you can build usage plans. It's the functionality that it's called on API Gateway. We have a basic, you know, free usage tier, for example, and then you can provide people with premium tiers, etc. So that's kind of more functionality of the API Gateway when you're talking APIs. And yeah, obviously you'd need to look into the specifics. It's very difficult to prevent someone from, you know, just getting another email address and pretending to be someone else. But you know, we capture all the data, and we can definitely help you identify, you know, people coming in from the same IP address and that kind of thing. But as far as I know, it's not something that the service just does natively today. But building in checks like, you know, SMS authentication, for example, requiring that becomes a bit of a barrier, because now, you know, it's slightly harder to get an SMS address than an SMS number than it is to get an email address. Though it's not impossible either. So
yeah, but it's making more difficult.
It makes it more difficult,
so that
yeah.
people yeah, it's just becoming a pain, and then they will give up soon.
Yeah, exactly. Yeah.
I just want to know what is the option available for AWS. So in one of the application is barcode we need to scan for mobile device, so that we can say what is the cost of this mobile, if it is grade, everything. So in that one, we use our like local machine, attach the device, and scan it. Yeah. So India AWS, it is not on website. So AWS do some hardware feature, like suppose the application is on premises or something which needs to be installed locally. Is it about like workspace?
I think the short answer is no. The longer answer is we have got some devices that go on to hardware. So we've recently announced Greengrass, yeah. So Greengrass, which is an IoT development environment, I guess. So if you're building an IoT type device, you can license Greengrass, and Greengrass will provide you with local storage, something like Lambda, but that can run on your IoT device. It provides the security in terms of talking back to AWS services. So if you're building a device, Greengrass would be interesting. So yeah, if you're building say an IoT device that happens to scan barcodes and communicates with backend services, that would be interesting to look at. But I think for your use case, to be honest, it's simpler just to do it locally. If it's a barcode, yeah.